In this section, we're gonna cover nearsightedness, or its similar name, myopia. This problem is actually taken from an exam from Berkeley, and I'm just gonna stop a little bit so you could read. So the problem is asking us to express f1, which is this lens, in terms of L, W, and delta x. And the first thing we do is we define the problem. So for a nearsighted person, they do not have a clear vision at infinity. So they do not have a clear vision to very far things. So for example, they would have a far point at 100 centimeters. This is not included in the question. This is just an example of what a nearsighted person is. So the eye's lens is not is refracting the light rays too much, that the image is formed in front of the retina that gives the person a blurry image. So for example, the light ray would form like this. The image is formed in front of the retina and it is not a clear image. So the lens acts as an accommodation to decrease the power of the eye's lens. That means that the glasses is actually a diverging lens. Since it is a diverging lens, the focal point the focal length, it should be negative. So when we're considering the object at infinity with glasses, we have two surfaces. We have two lenses. So that means there is two image formation. So we have to look at both image formation. We could look at the first image formation first. So we're looking at this. We are looking at this diverging lens. For this diverging lens, we're assuming that it is a thin lens. So we could use the thin lens equation. We have this. And we assume that the eye's lenses are also thin lens. So we could use the thin lens equation again. We're looking at the second image. So we just plug in the values to it. And notice that I uses L plus F1 since F1 is negative. So this distance, I'm talking about this distance, it has to be positive because it is a distance. So I just use absolute value. Or I could use negative F1, but in this case, I feel like I use absolute would be more appropriate. And then the next thing is we're trying to solve F2 in terms of the variables I have, which I cannot relate in considering that case. So we have to consider the object at infinity without glasses, that the image would form at this point. So we apply the same equation, the thin lens equation, and we could express F2 in terms of the variables I have. So after I plug in F2 with the variable I have this equation. And since F1 is negative, I have to put a negative sign to whatever answer I have. So that is why I have the final answer as this thing. And this explains what a nearsighted person could see and what nearsighted means, what nearsightedness means.